Hi, I'm Kyle D'Souza, and you're listening to the WA School of Mine's Alumni podcast. Finding new oil and gas has never been easy, and it's only going to get more difficult. Making sure the oil and gas industry has people ready for future challenges requires universities and industry to work together. Chris Elders started as an exploration geoscientist over 30 years ago. Now he resides as Professor of Petroleum Geology at Curtin University. Welcome, Chris.
Good morning.
What is petroleum geology, and how does it differ to how the mining industry understands geology?
So petroleum geology is understanding all the different aspects of how petroleum forms, how it moves around in the subsurface, how we can identify places to drill in order to find it, and then also to some extent how to produce those deposits. So in some ways that's quite similar to mineral exploration. With petroleum geology, we're generally looking at deposits that occur at much greater depths, so use a lot more different techniques like seismic data in order to understand what's going on 2, 3, 4 kilometers below the surface.
What drew you to focus on petroleum geology?
When I finished my PhD, I was looking at different career options, and I had the opportunity to work with Shell. I was working as an exploration geologist in the Netherlands, and that opened up a whole new world to me. So I found that really interesting, and then had the opportunity to move back into academia to train people to enter that industry.
What other places has your work taken to, and which region stands out as a favourite and why?
Well, I've looked at data from pretty much every continent on the Earth. That's the really interesting thing. The places I've really enjoyed visiting are Thailand and Indonesia. I also did a lot of work in Russia, which was a fascinating place to visit.
Fantastic. And what was it exactly about Thailand and Indonesia that makes it your favourite places?
Really nice food in both places. But the geology of Thailand is really interesting. That was where we were doing some research that sort of helped us to understand some of the processes that create the sedimentary basins in which oil and gas deposits occur. We were looking at some fault zones in southern Thailand that run across the Thai peninsula. They had been described in the 1960s just on the basis of air photos, and no one had really ever been to look at them. They had been described a little bit by the Geological Survey, but not in much detail. And there were other faults that had studied, so people assumed the observations they'd made on other faults also applied to these faults. And what we actually found out was that the story of those faults was quite different to what people had previously assumed. It really was frontier research.
With the world moving to, say, more sustainable sources of energy, how are you seeing your space in petroleum geology change?
Yeah, well, that is a very interesting question. And obviously, there is going to be a transition to increasing use of renewable energy. And a lot of people see gas as a relatively low carbon transition fuel while we make that change. So that's one area. But the other issue is that there's always going to be a demand for what you could call very high density fuel. In other words, where you can get a lot of energy from a relatively small amount of raw material. So for instance, for planes and a lot of different aspects of transport. And there's a lot of interest there at the moment in terms of developing hydrogen as a fuel. And of course, one of the places where hydrogen occurs is in molecules like methane, which makes natural gas. So the question is, where do you get the hydrogen from? So rather than at the moment, we use the methane mainly for the carbon. In the future, we might use that for the hydrogen. So there's possibly a slightly unexpected longer term future for looking for the same raw materials, but perhaps using them for a different purpose.
What are the challenges in finding new oil and gas fields?
I guess the big challenge is that we've already found a lot. So the focus of exploration is looking for increasingly more subtle occurrences of of hydrocarbons. And that, of course, requires much greater skill as geologists to understand the places where the deposits might occur. Geology and exploration always throws up surprises, and there's been some very interesting recent oil discoveries on the Northwest Shelf, which have changed people's perceptions and maybe opened up new areas for exploration. So there's always new places to look, and it's a case of developing our knowledge as we find out more and sort of pushing the boundaries, really. There's been quite a big change in the way in which seismic data is acquired and processed over the past 5 or 10 years. That's something called broadband seismic. That enables us to see, and that helps us indeed to see things in greater detail. So we, to some extent, going back to our other areas, looking at things in a slightly different way, looking at in the same area at maybe different formations that haven't perhaps been considered prospective before.
How's the science of locating oil and gas deposits changed since you started as a geoscientist?
The big change that's possibly just around the corner is deep learning, machine learning, and artificial intelligence. That's something that hasn't been used very much in the oil and gas industry. People have suddenly realized that it has potential, and there's a lot of people now trying to find a way forward, how to adapt those techniques that are used in other areas to help us with the search for oil and gas. Some very interesting research that's going on here at Curtin University is, for instance, with the injection of CO2, so for carbon dioxide storage. When you inject the carbon dioxide, you can monitor that and see where it's going. So that's useful, but that's in the past. And what we want to know is what's going to happen in the future. So those techniques can be used to predict what's going to happen next rather than just measure what's happened in the past. And then those similar techniques can be applied to extraction of oil and gas, to already using something called 4D seismic. We can monitor the extraction of oil and gas. But if we can take that a step further, we can then predict how the reservoir will behave in the future, in addition to just seeing how it's behaved in the past.
What are the key aspects of petroleum geology that we're yet to understand?
I think at one level, we could say we have a pretty good understanding, but I guess we don't always understand the way in which oil and gas deposits are trapped, because obviously when wells are drilled, probably only about 30% or so are successful. If we knew everything, wells would be 100% successful. So it's understanding those aspects of the what controls the distribution, I guess, of oil and gas reserves. A lot of that to do is the seismic imaging is becoming ever better, and artificial intelligence may become even more sophisticated still. But it's perhaps the very basic bit of how the organic rich source rock forms in the first place, and how that organic material gets converted into oil and gas, which is perhaps where we still need to develop a lot of understanding.
What are the perceived barriers for industry funding research?
I would say that in geology, there's a very close relationship between academia and industry, because we're studying basically the same thing and people have the same interests. There's an awful lot of overlap. So generally, I would say the relationship is good. The challenges, obviously, with regard funding, mainly revolve around the financial state of the industry, I guess, primarily. So when commodity prices are lower and there's less surplus revenue within the industry, then being able to afford that extra bit of spending on research is much more challenging.
What do you think makes a successful geoscientist?
Someone who can think a little bit outside the box, someone who can integrate lots of different bits of information, see the big picture, maybe not always accept the perceived wisdom, but perhaps see what new things all that information is telling them, and then obviously being able to integrate that and develop new ideas.
Continue this sentence in terms of what you'd like your students to say later on in life. From Professor Elders, I learned.
Yes, I think that's quite a tricky one, actually. I guess that enthusiasm for geology, that understanding, and the sort of love of the subject, and being able to see not just that as an end in itself, but how they can apply it in a practical way. That's what I hope they come away with.
Well, thanks so much, Chris, for joining us today.
Thank you very much.
Ladies and gentlemen, that was Chris Elders, Professor of Petroleum Geology at Curtin University. I'm Kyle D'Souza, and this is the WA School of Mines Alumni Podcast. And you can find us by simply searching on any search engine, WA School of Mines Podcast.